So right now we're looking at data from experiment number 2 from your current balance lab. This is the experiment where you're manipulating the length of the wire and then responding to that was the magnetic force. The data table would look something like this. First column, length of the wire in centimeters, and the second column was this so-called mass as measured in grams. Now, remember, we're not really measuring mass. The scale was tricked into thinking that there was more mass. In the end, that mass we're going to multiply by 9.81, convert it to kilograms, multiply it by 9.81 to get the value of the magnetic force. What I want to do here first is copy what you see up there into a new spot. I'm going to copy it over here. Let's start in column E. We'll paste it there. Well, now, why am I doing that? Because in the end, I don't actually want my length in centimeters. I want my length in meters. Now, probably the easiest way to convert it to meters, if you didn't already record it in meters, some of you may have. If you've recorded it in meters, then you can skip this step because you've already got this done, right? If you recorded it in centimeters, the easiest way to convert it to meters is to create a formula. So for that block right there, that cell right there, I want to take cell A2, that's column A, row 2, that's the number that's 8.4, I'm going to divide that by 100. Instead of saying 8.4 divided by 100, I'm going to say A2 divided by 100. The benefit of putting that in as a formula as opposed to just putting the number in is that I can actually take the formula there, click and drag that bottom right-hand corner, and copy the formula all the way down and do that calculation for all of my trials just by entering the formula once. So now I've got my new data table with length in meters and my mass still in grams. Now my third column on my data table is going to be my magnetic force. And that magnetic force is going to be measured in newtons. That magnetic force is going to be the mass in kilograms times 9.81. But I've got my mass in grams there. Let's convert that mass to kilograms and then multiply it by 9.81. We're going to do that by, once again, entering a formula. Equals, you always press equals when you're entering a formula. It's going to be equals, we're going to say brackets, F2, it's column F, row 2, divided by 1,000. Okay, it's at 0.68 divided by 1,000, and then I want to multiply that by 9.81. That gives me a magnetic force of 0.006671 newtons. Now I can take that one, click the bottom right-hand corner, and drag that formula down as well. Now I have all my values of magnetic force. Let's tidy this table up a little bit here. Okay, first thing I want to do is stretch each of the columns out a little bit so that everything fits in the column. Right, magnetic force is too wide of a heading to fit in the one column, so I make my column a little bit wider. Next thing I'm going to do is tidy it up by maybe centering everything. Looks a little bit nicer. Next thing I'm going to do is, I see in that second column there, mass in grams. I see sometimes it's 1 decimal place, sometimes it's 2 decimal places. Let's make it 2 decimal places for all of them. Okay, so now we got 2 decimal places by clicking on this little button up here. Magnetic force, let's do the same thing. You can tidy this up by going to 2 decimal places for each one. Okay, there we go. Okay, I've got a much nicer looking table right now. One final thing I can do to tidy this up. Let's click on borders up here. Draw borders around all of it. Okay, that's a much better looking table, a much better formatted table than what I had before. All my numbers are there, and it looks good. Now let's plot the graph. To plot the graph, we're going to highlight the data from my last column, from my y-axis. Okay, don't highlight the entire thing. Don't highlight the word magnetic force. You start here at the first number, highlight downwards. Then we're going to go insert. We're going to insert a scatter plot. See the funny looking graph I have? This should not go downward, it should go upward. And if you look closely at the numbers on the x-axis, it just doesn't work out. I don't know where they came from, to be honest. I'm not really sure. I think it might be trial numbers or something like that. Okay, that's not what we want. Okay, we want the length of the wire on the x-axis and the magnetic force on the y-axis. So here's how we're going to get that. My y-axis is good. Let's click on one of the data points, right-click, then click Select Data. Click Edit. Now you can see the y-axis is good. My y values, if you look right here, it says it's column G, row 2 through row 7. So column G, row 2 through row 7, and that's exactly where I should be for my y-axis. Column G, row 2 through row 7. But my x values aren't there. So let's click on this little button right here under Select X Values. Let's highlight my x column. Let's press that button again. And now that graph looks a lot more like it should look. It's a straight line graph, and you can see on my x-axis, it's now the numbers that appear in that first column. Let's click OK. Let's click OK again. Now the graph is essentially what I want it to be. Let's click on Chart Layouts. It's the first one that I want to click on here, because that's the one that's going to give me an opportunity to fill in my chart title, which is going to be Magnetic Force versus length of wire. Then I'm going to click on my x-axis. I'm going to change the title there from axis title to length of wire. And I'm going to make sure I put that in meters. Do the same thing for the y-axis, except it's going to be magnetic force. And the units are going to be newtons. Now finally, I want my line of best fit and I want my slope. So let's click on one data point. Let's right-click. Let's click Add Trendline. Let's make sure that linear is highlighted there, filled in. It should be automatically, but if it's not, make sure you click that button. And then click Display Equation on Chart. Click Close. There's the equation. Y is equal to 0.0768x plus 0.0002. The y-intercept is so small that it doesn't matter. The slope is 0.0768. Okay, that's the value that we really want there. You can tidy this up a little bit more by clicking on this and getting rid of it, although that's not really a huge deal. Now we want to put this into Microsoft Word so that we can have a nicely formatted lab right up here. First thing I want to put is data. Let's highlight our data here. The data, remember, is your first two columns. Copy that. Paste it. Now it's time for analysis. Let's copy my analysis table, which is all three columns. Let's put that into Microsoft Word, paste it. There's my analysis table. And then finally, of course, I need my analysis graph. Click the top right-hand corner of that graph, copy it, and then paste it once again into Microsoft Word. You can resize this if you want. In fact, you should. It's probably going to come out to be a fairly small graph when you copy it into Word. Make sure you resize it so that it's a decent size. Take up as much space as you can, basically from one side of the page to the other side of the page. Okay, if you need to move this around at all to make it a little bit neater, you can still do that. Should be good to go. At this point, you got to go back and do experiment number 1, right? This is the data for experiment number 2. You got to do the same thing for experiment number 1, and you've got to find the magnetic field strength due to experiment 1 and experiment 2. The process of doing that, pretty much got to do that by hand, and we explained how to do that on Friday. So if you forget that, check the podcast from Friday and refresh your memory on that. Is there any questions on that? Yeah. Does this make some sense? How long did that take me? If we look at this, the timer here, it's 9 minutes and 14 seconds. Okay. If I had just been doing that and not demonstrating this for you, it probably would have taken me, what, 3 minutes? If I have to do that again for experiment number 1, then it's going to take me, what, 6, 7 minutes total? Add a few minutes to do the rest of the analysis, the calculation of the magnetic field, and I'm at no longer than 15 minutes. So if you do it with Microsoft Excel and you're fairly proficient with it, you should be able to write this up really, really quickly. All right, no questions? Okay, good. Lab is due on Wednesday. I don't care whether you do it with Microsoft Excel or whether you do it by hand, but if you want to do it quickly, and well, then your best bet, I'm suggesting, is Microsoft Excel.